Hi, if you saw my dumpster diving video, you know that I scored two of these Samsung SyncMaster 204B monitors with the nice portrait tilt-in stand on them. Excellent. And I assume they would work because I have got monitors from down there before that have worked no problems at all. But unfortunately, these two don't look like they work at all. The light doesn't come on. I've tried to hook them up to a PC. Nothing. Usually you should get some sort of menu or something like that. So it looks like these things are cactus. And of course, in all these sort of things, well, pretty much most electronics gear, like consumers and computers and set-top boxes and all sorts of things. I think I've done a video on that before. One of the most common culprits, of course, is the electrolytic capacitors in them. They fail bad. And I had a whole bunch of comments on my dumpster diving video that these Samsung SyncMasters are notorious for having bad quality caps in them. So I thought we'd open it up and try and replace the caps in it and see if it fixes the problem. Or check them out first and see if that's the issue. Probably, I reckon with about 90%, 95% certainty maybe, it will be the caps in the power supply, because electronics is pretty reliable, just regular active and passive components, very reliable, but electrolytic capacitors, of course, have a dielectric liquid in there that can actually dry out with use and when they get hot, and these things get reasonably hot inside. And I've done videos on this before, so almost certainly it's got to be the caps. Let's crack it open. And I can't see any screws on this thing. I think it's a plastic retaining clips around the edge. What a bastard. Spudger time. Well, that was pretty annoying. And now you've got to, it just looks like it just lifts out now. I would have preferred screws. Hate those plastic retaining clips. We've got a, there we go. Back panel just lifts off, real easy. This thing is quite heavy. It's really well shielded. As you can see, it's built like the proverbial brick outhouse. I like it. And it looks like this front panel connector just comes off the switch. Front panel switches, and bingo, we have our screen. We can now open this sucker up. We should only have to get into this top access panel here, and that should give us access to the power supply circuitry under there. I've lost my good Phillips screwdriver, unfortunately, so I'm going back to the old one I've had since I was a kid. I had that since before I even turned 10, I think. That's how long I've had that screwdriver. So let's have a look. 2 screws there, doesn't sound right. What's going on here? That's all integrated with this. It's folded, this is all folded over the top and integrates with, it's rather annoying. There we go. All right, couple of screws on the side, and then this whole top bracket should just lift off. There we go. Yep, beautiful. And as you can see, there's not much to this thing, just the 2 main boards here, and instantly, I mean, all we care about is the power supply one over here. I mean, we've got some backlight inverter stuff here. This is the mains power supply section, and hey, we've got it straight away. And look, they're dodgy. Capson brand. Can you believe that Samsung use Capson? That one actually looks okay. There's no bulge in it, but these are also Capson brand up here, which I'll give you a look at. And these are dodgy. Look, you can, I don't even have to measure those. You can see the bulges in them. And the choice of those caps is quite surprising, because this is an otherwise very nicely engineered and laid out, mains switch mode power supply. They're doing all the right things here except for the choice of caps. It's actually very nicely laid out, and they're doing all the right stuff here. They've got transorbs, they've got thermistor, they're elasticing those over so that they don't vibrate loose. The main DC input filter cap is elasticed down. It's all happening. They've even got the dip marker to show how it, which direction the board flows through the dip soldering machine, you know, the wave soldering machine, and lovely. And here we go. We have some caps on, 25 volt, 330 microfarad. You can see the bulge in the top of the cap near the vent hole there, and that's a dead giveaway that there's been pressure build up inside there, which means that all the electrolyte fluid has dried up, and of course this one has actually vented out. Check it out. That's an 820 microfarad. You don't see 820 microfarad too much these days. You know, usually it'd be like an even 1,000. But there you go. 820 microfarad, 25 volt, caps on. Absolute classic case of electrolytic capacitor rupture there. It's gone bad. I don't even need to get out my Bob Parker ESR meter and measure those. I know they're gone bad. Anytime you see a bulge in an electrolytic capacitor like that, you know it's gone and you've got to replace it. And we've also got some caps on 330 mic 25 volt ones on this side here, and that one has a slight bulge in it too. The one behind it seems to be okay, but as a matter of course I'm going to replace all of these caps on brand caps. Now I'm not sure if I'm actually going to replace that main DC input filter cap, the mains input filter. That's 100 microfarad, 450 volt, because I can't see any signs of bulging in that at all, but it is a Capson brand, so it instantly you know, brings into question, even if I didn't know what brand it was. If you see that the same brand are all leaking and bulging over here, you got to assume that you're going to have a similar problem with this one. But I reckon I can probably fix this thing by just replacing the DC output caps, because these are the main output caps on the main DC rails which power all of your electronics here. And of course, if they're no good, if the all of the electrolyte fluid in there is dried up, or the pressure's built up in there, then of course you're not going to get a nice smooth DC rail to power your electronics. You're going to get tons of ripple on there, and all your digital electronics is just going to play silly buggers and not going to work at all. So yeah, I don't know whether, it depends on how much they cost and whether or not I can get them from Jcart now, because I want to fix this one like now in the next hour. So, or both of these monitors. So I reckon I could probably get away with not replacing that one. It's not great for the long term, but anyway, for the short term fix, I reckon just the output ones. And if you're interested in seeing the main board, here it is. It's got a date code on there of 2007 by the looks of it, but it's pretty much just a single chip solution, as you'd expect these days. You know, here's your input connector, your DVI, and your VGA. It's all in one chip. Geez, I can remember monitors. I can remember working on flat screen monitor designs back in 1994, I think it was, about 94-ish, and to do what they're doing inside this monitor, even at lower resolutions like 800 by 600 at the time, this is before widescreen really kicked in, was hideously complex, and it required a board full of chips just to digitize the VGA input and convert it to flat screen. Now it's just one little QFP package. Thank you very much. And you can see the RF ferrite bead there for EMI suppression, so that will knock some of the edge off those digital signals, high-speed digital signals flowing through that parallel data link there. And of course there are some surface mount electrolytic caps on this logic board, but really, you know, I don't think they're going to be a problem at all. It's definitely the ones on the main power supply board. And you can see on the back of the board here, they've got some insulation, actually very nicely clipped into the main board. I really like that. Samsung have really gone to quite a bit of effort to design this thing properly, which is all the more disappointing why they're using crap quality caps in this thing. Check out the bottom of the board here with its nice sexy black solder mask on green. It really does look very nice. I really like it. They've engineered this thing quite well. As I said, look at the high voltage isolation slots they've routed into all this stuff. Someone's put a bit of pride into this layout, let me tell you. It's beautiful. And we've talked about this before in other videos. You can see the selective removal of the solder mask on those traces as they thin down. You see how they're fatter here and they thin down here, and just to increase the current capability of those traces just a tad. And they've done the same thing down here on the main. This is the mains input switch here, the IEC connector with the main switch, and they've done same thing there. So after a quick trip to JCar, I picked up some dubious brand low ESR capacitors here. I say that because JCar don't exactly have a stellar reputation for supplying prime spec quality parts. It's like whatever they can get really, and these are SI brand, never heard of them. I don't know, don't trust them as far as I can throw them, but it's the only choice I had. If I wanted to do this properly, I would have gone to Farnell's much further or ordered them. I can't wait. I wanted to fix it within the hour, so these are the best that I could do. 470 microfarad, 25 volt, replacing the 330 microfarads. If you're going to replace these, don't go down in capacitance value. If anything, go up. They didn't have any 330s, so I'm using 470, 25 volt. They're a bit physically bigger, but they are 105 degrees C rated. That's what you want because the life of capacitors drops with an increase in temperature, and if you've only got 85 degree C rated ones, they're not really good enough. And it's a low ESR type. That's what you want with switch mode power supplies like these. You don't want regular capacitors, low ESR. Trust me, that's the business. So I picked up that, and I picked up a, once again, SI brand 1000 mic, 25 volt, once again, low ESR. Physically quite a bit larger. I think it's the same pin pitch here, but hey, beggars can't be choosers. It's all they had. You know, if I went to Farnell's, yeah, I could have picked up just exactly the right cap that I wanted in the slim profile and, you know, a quality, reputable brand sourced from the, you know, the known reputable supplier. But anyway, we'll throw these in. It'll get it up and running as long as they physically fit. Let's give it a go. So there you have it. I've replaced 5 caps here. These ones, as you can see, they weren't physically the same diameter. They were a little bit wider in the diameter, so they don't quite fit in there that well. But anyway, good enough. It's going to work. I didn't bother to replace the mains input cap because they were like $7.50 each at JCar. Screw that. But these ones only cost me, you know, $1 or $2 total. So hopefully that will get us up and running. All right, let's power this thing up and see if she works. Here we go. Hey, the LED, you probably can't see that, but the LED is consistently on and it's working. Look, ta-da, analog, digital, no problem. Does menu work? So there it is, check signal cable. That is working a treat. I'll put the front panel, clip that back on, and no worries. I'm sure if we hook that up to the VGA output of the notebook or the DVI output, it'll work a treat. Beauty. And here's inside the second identical monitor. The main input filter cap looks fine. Once again, the same caps on brand. These ones look okay, but I'm going to change them as a matter of course. And there we have the Bulgies. There they are. Wah. And the second monitor, I've replaced all the caps in there. Lights coming on, and bingo, there it is, fixed as well. No worries whatsoever. Ha! And there it is. Works perfectly, both of them. So there you have it, 2 repaired Samsung SyncMaster 204B 20-inch monitors I got from the dumpster. Good old dumpster diving. Fantastic. Fixed with 10 minutes work and a couple of bucks worth of caps. And these are excellent monitors. Beauty. And there's probably some poor design engineer at Samsung right now just doing a big face palm because they designed and built this thing beautifully only to have some dickhead in the purchasing department purchase dodgy caps instead of probably the Panasonic ones they specified in the bill of materials. You know, purchasing just, oh man, we'll get the cheapest caps we can. We're going to make 1 million of these monitors. Oh look, I saved the company, you know, 50,000 bucks in capacitors. Beauty. Not. And just remember, when you're fixing bad caps like this, to replace them with good quality low ESR types. The low ESR is important because it's the high ESR that causes the internal heating and then the pressure buildup and the drying up of the electrolyte inside the capacitor that causes all these problems in the first place. So they're a bit self-perpetuating in that respect. If they start out, you know, a little bit dodgy, then they're going to heat up a little bit inside. That extra heating increases the temperature inside the cap, increases the ESR, equivalent series resistance, which then increases the heat even more, dries out more of the electrolyte, and so on and so on, and it just snowballs until it just spews its guts and stops working at all, like we saw in these monitors. And lots of stuff, lots of consumer items, PCs and set-top boxes and DVD players and TVs, a lot of them will be an easy fix like this by just changing the caps in them. And if you like the video, please give it a big thumbs up. That helps a lot. And if you want to discuss it, jump on over to the EEVblog forum. Catch you next time.